Hi everyone, Mrs. Gifford here, and this lesson is all about elimination using addition and subtraction. And after this lesson, you will be able to solve systems of equations by adding and subtracting. There should be a G right there. Okay, so we're going to take a look at solving systems of equations. So far you've learned how to do it by graphing, and now we're going to talk about how to do it with solve by either adding or subtracting. I'm going to add in a little window here just so you don't have to cruise ahead. So the question is, how do we solve systems of equations by addition or subtraction? Now, just a reminder, good students try to figure out ways to abbreviate to help with keeping up with the pace of a lesson. The other thing is you can find this on YouTube as well. So let's take a look at the first step. The first thing that we're going to do is set the equations so that the like terms are lined up vertically, kind of like an old-fashioned addition or subtraction problem. Step number 2, you're going to add or subtract your two equations to eliminate one of the variables. Step 3, just like before, you're going to solve for the remaining variable. Oops. And step 4, you're going to substitute that value into one of the equations and solve for the other variable. And like previous, step 5, the solution will be an ordered pair. So let's take a look at some examples. The first one here, example 1a, we have 4y plus 3x equals 22, and we have 3x minus 4y equals 14. And so we're going to use these equations to solve the systems. Oops, that's a typo. So anyway, we're going to solve the systems of equation by addition or subtraction. So the first thing that we need to do is take a look at our two equations, and I see in each of our equations the first one has a 4y and the second one has a negative 4y. So I'm going to rewrite those equations so those 4y's are stacked on top of each other. So our first equation stays the same. Then I'm going to put the negative 4y in front. And since this 3x is positive, we're going to say plus 3x equals, and then that 14 stays the same. Now, as you can see, I have these two opposites, 4y and negative 4y. They're stacked on top of each other, and when we add opposites, they cancel, so they are eliminated. And we're going to add these two equations together, and 4y plus negative 4y is 0y, and 3x plus 3x gives us 6x. Bring my equal sign down, and 22 plus 14 gives us 36. And now we just have a one-step equation to solve, and so we're going to divide by 6, so we get x equals 6. Now we are not completely finished because not only do we need an x value, we need a y value. So as we said in the steps, once you find this first value, then you go to one of your two equations and put your 6 into one of those two equations where the x is, and then solve for y. I'm just going to pick that first equation, so I have 4y plus 3, and I'm going to take x out and put 6 in its place, equals 22. 3 times 6 is 18. And now we are going to solve our systems of equations using the two-step method. So we're going to subtract 18 from both sides because our goal is to get that y to be by itself. So I have 4y equals 4. And then my last step is to divide by 4. So we get y equals 1. So now that we have our x value and now that we have our y value, then we know that our solution can be written as a coordinate pair of 6, 1. So that would be your final answer. If you were going to graph these, this is where those two lines would intersect. Let's take a look at the next one. So it's the exact same thing. Now notice in this case, in example 1b, we have negative 3x plus 4y equals 12, and we have 3x minus 6y equals 18. And the nice thing about this one is our opposite terms are already stacked on top of each other, so we do not need to rearrange either of the equations. And because they're opposites, we are going to add the two equations together. And we do that so these two are going to cancel each other out. And we have 4y plus negative 6y. 4 plus negative 6 is negative 2. And then we have 12 plus 18, which is 30. And like we did before, we're going to solve for y. And we're going to do that by dividing by negative 2. And y equals negative 15. Now, we're not quite finished because not only do we need the y value, we also need the x value. Excuse me. So I'm going to take that negative 15 and put it into our first equation. Again, you can pick either equation, but I'm just choosing to use the first one. And so I took the y out and put negative 15 in its place. 4 times negative 15 is negative 60. And now we're going to add 60 to both sides. So we have negative 3x equals 72. And what do we do to solve from here? We actually have to divide by our negative 3. So we have x equals, and then I'm just going to do 72 divided by 3 over here. 3 goes into 7 2 times. There's 6. 1, bring my 2 down, and 3 goes into 12 4 times. So 72 divided by negative 3 gives us negative 24. Again, once you have your x and your y value, then you write that as a solution, or you write your solution as a coordinate pair of negative 24, negative 15. So in these first two examples we've done, we've looked for opposites. When we see opposites, we are going to add. When we see opposites, we're going to solve by adding. Okay, solve by adding. So now let's take a look at two other equations where we don't have opposites, but we have the exact same thing. And when we have the exact same thing, instead of adding, we are going to subtract. So, excuse me, we're going to solve the systems of equations, and we're going to do that by adding or subtracting. In this case, as we take a look at these two equations, we have the same term. When we have the same term, we are going to subtract. And the reason why we subtract is because we want to eliminate one of these options. So we have 8b plus 3c equals 11, and we're going to subtract 8b plus 7c equals 7. Again, we're subtracting because 8b minus 8b, those two cancel. 3c minus 7c is negative 4c, and 11 minus 7 is 4. From here, we're going to divide by negative 4, and so we get c equals negative 1. And just like before, not only do we need one value for a variable, we need to figure out the value of the second one. And I'm just going to pick the first equation. Again, you could have picked either equation, but I have 8b plus 3 times negative 1 equals 11. And then I have 8b minus 3 equals 11. And now I need to solve for b. So I need to get rid of this minus 3, and we do that by adding 3. And we have 8b equals 14. And did I want to get a decimal here? Because 8 does not go into 14 evenly. Sorry about that. Let me look at my notes real quick. 8b, what did I do? Nope, we are going to get a decimal here. So then from here, sorry about that, I just wanted to make sure, but we're going to divide by 8. And so we get b equals, and let's see, 8 goes into 14 one time. There's 6 left over, and we have 8 as our denominator, which simplifies to 1 and 3/4. If you choose, you could write it as a decimal as 1.75. So then our coordinate pair again, this is our solution for B. So our final solution for the systems of equations is going to be, we're going to do it alphabetical, so I'll put my 1 3/4 for my B variable, and then I have a -1 for my C variable. Again, alphabetical order, and just like before, we add when we see opposites, we are going to subtract when we have the same. Okay, so one way to think of it is opposite and add both start with a vowel, and subtract and same both start with S. One way to remember. So let's take a look at our last example here. We have 2x plus 4y equals 28, and we have -3x plus 4y equals 18. So what do we see in these two examples, or these two equations? We see that they both have 4y, and they are the same, and when we're the same, we subtract to solve. And again, we do that because we want to eliminate one of the terms. And so we have 2x minus -3, 2 minus a -3. Subtracting a negative is like adding a positive, so we get 5x equals 28 minus 18 is 10. Just like all the other ones, divide by 5, so we get x equals 2. Are we done? No, we're not, because we only have the x value, so we're going to take this x and put it up into one of our equations. Again, I'm just picking the first equation. You could pick either. I took the x out, put the 2 in its place, and 2 times 2 is 4. So 4 plus 4y equals 28. I'm going to solve for y, so I'm going to subtract 4. Again, we're trying to get y by itself. So we have 4y equals 24. And then we divide both sides by 4, so we get y equals 6. So we have our x value, we have our y value, so our solution to the systems of equations is the coordinate pair of 2, 6. So that is solving by elimination, with elimination using addition or subtraction. Again, we add when we see opposites, we subtract when we see the same terms. There you have it.